Welcome to Chemazon-Complete Chemistry. So in this video, we are going to solve this another question that was asked in December 2024 paper. So here you can see this is the starting material and this is the final product. So here, okay, and these are the sets of reagents that were given. Okay, so here you can see heat is given. Okay, so what type of reactions take place in presence of heat? So mostly the most common first thing that should come to your mind is a type of a pericyclic reaction. Okay, so you can see here there is this sigma bond. Okay, so this gives you a hint that something will happen to the sigma bond. That is a type of pericyclic name reaction that is called as sigmatropic rearrangement. Okay, so a 3-3 sigmatropic rearrangement will take place, and there is, you can see the number of carbons here, it is only 1 2 3 4 5 carbons, whereas here 1 2 3 4 5 6 7 8, here there are 9 carbons, so 4 carbons are extra. So from where do we will get 4 carbons? From this butyl bromide. Okay, and butyl lithium is the base. Okay, so we know that somehow at some stage we have to do alkylation. So the question is, at which stage? Before doing sigmatropic we have to do alkylation, or first you do sigmatropic and then do alkylation? So that is a question. Okay, so if you do a sigmatropic reaction first and then you try to do alkylation, that will be not possible. Okay, so first let us try to do the sigmatropic shift. So 1 2 3 1 2 3. Okay, so 1 bond will break like this. Okay, 3 bond will join here and this will fall here. Okay, so we have sulfur, that is 1, then carbon 2, and then 3. Okay, so between 1 and 2 there is a double bond like this. Okay, and then between 2 and 3 there is a single bond, then 3 forms bond with 3, 2, and then 1. Okay, 3 there is a single bond. Between 3 and 2 again there is a single bond, and then between 2 and 1 there is a double bond. Now here, okay, this is like an aldehyde. Okay, so here if you do alkylation, okay, this is similar to a normal aldehyde, only instead of oxygen here it is sulfur. Here if you do alkylation you will get 1 2 3 4. Okay, here you will get this 4 carbon, that is N-butyl. N-butyl means normal butane, 4 carbon chain. Okay, straight chain. So you will get this product. Is this the product that is required? The answer is no, right? We need a linear product and not a branched product like this. Okay, so that is why the first thing is you have to do the alkylation. Okay, now here which is a more acidic proton? So here if you see carefully, this is the acidic proton. Okay, why this is acidic proton? So butyl lithium first, okay, it will abstract this proton and form a carbon ion. Okay, what we will get? We will get this. Now why this is stable? There are two reasons. One is it is stabilized via resonance with this double bond. The another reason is that this negative charge, it can participate. Okay, sulfur has vacant d orbital, so it can participate in a back bonding. Okay, back bonding with sulfur. So that is why this carbon ion is stable. So after forming this carbon ion, what will happen? We have formed this carbon ion, sulfur, double bond, and now this will attack the butyl, N-butyl bromide. Okay, so N-butyl means 1 2 3 4 carbon straight chain and then bromide. So this will attack the bromide, this carbon, and bromide will go away as a good leaving group. So what we will get? A double bond, then here sulfur. Okay, here we have 4 carbons, so 1 2 3 4 like this. Okay, so now here we will do the 3-3 sigmatropic shift. Okay, so 1 2 3 1 2 and 3. Okay, so we'll start from sulfur. Sulfur is 1 2 and 3. So between 1 and 2, okay, so 1 bond will break like this. then 3 new sigma bond is formed, and this will shift here. So between 1 and 2 a pi bond is formed, 2 and 3 is sigma, then 3 and 3 is also sigma, then 3 and 2 again it is sigma, and then last 1 and 2 there is a pi bond. So here you have got this, and then at the first carbon, okay, first position there is a 4 carbon chain, 1 2 3 4 like this, okay, or we can label it 1 prime, 2 prime and 3 prime, okay, to know the difference. So this is 3 prime, 2 prime and 1 prime. So at 1 prime we have the 4 carbon chain that we have drawn here, okay. Okay, so this was the second step, and last step is what? It is hydrolysis. Okay, always remember mercury is used to remove sulfur. Okay, that reaction is called as a desulfurization. Okay, and so here we do hydrolysis of this bond and we will get a aldehyde, COH double bond, and then there is 4 carbons. Okay, so this is the product, aldehyde, and then there are 2 carbons, okay, you can see, and then a double bond, and then 1 2 3 4, okay, 1 2 3 and 4. Okay, so what is the correct sequence of reagents? So first what we did, we reacted with butyl lithium, and butyl lithium will be first, then you add N butyl bromide. Okay, then we do 3,3 sigma tropic shift that will take place in presence of heat, and last one is removal of hydrolysis of the carbon sulfur double bond to form the aldehyde. Okay, so the correct answer would be what? Correct answer here, it is going to be first butyl lithium, then butyl bromide, then heat, and then mercury. So the correct answer here is option 2. Okay, that's it for this video. In the coming videos we will solve some more questions. I hope you have understood this reaction and why this is called Thio Claisen rearrangement, because of this sulfur. Okay, thank you.